Let's take a close look at our particular systems. In this particular case, we have two nodes, and we are using Oracle's VirtualBox. We have node 1, and for the VirtualBox name, we're actually named that RAC 11G R2 node 1, and that's currently up and running. Then we also have RAC 11G R2 node 2, and that's currently up and running. Each node is named accordingly. We have RAC 1 for node 1, and then we have RAC 2 for node 2. We have already set up the networking requirements, and over here on node 1, I'm going to come over here and let's go ahead and take a look at the etc host file. So I'm going to go ahead and do a VI on the etc host file. In every single RAC environment, you will need to have 3 IP addresses set up. You will have a public IP, you will have a private IP, and you will have a VIP. In Oracle 11G, we also subscribe or use a scan listener. The scan listener stands for Single Client Access Name. The IP address for node 1 is what we see here is 192.168.2.101. Its host name is RAC 1. For RAC 2, we have 192.168.2.102, and its name is RAC 2. The private IP address is 192.168.0.101, and its name is RAC 1-priv. And for RAC 2, we have it named as 192.168.0.102. Now this is very important. In our environment, we actually have 2 network cards. The first network card is going to be bound to address 101, and you'll notice that is on subnet 2. The private network card is bound to 101, and its subnet is 0. So we see that we have the VIP, and we can see that the VIP is also on subnet 2. It's very important to note that the public IP address and the VIP has to be on the same subnet. The private is going to be on a separate subnet. This VIP is not going to be configured until we do the install. And then we have the single client access name. Since we're using etc host, that should be set up too, and you'll notice that that is on the same subnet as the VIP as well as the public. So let's go out and make sure that this networking is all set up as well. So I'm going to go ahead and quit out of here, go over to System, Administration, and I'm going to come down here to Network. The password here is going to be Oracle, and we can see that for ETH0, this is actually your public IP address. To verify this, I'm going to go to Edit, and I can see that ETH0 is going to be bound to 192.168.2.101. It does have a subnet mask as well as a default gateway. I'm going to go ahead and cancel out of here. Now I'm going to go to ETH1. If I go to Edit on ETH1, and this is very important, we can see that it is bound to IP address 192.168.0.101, and there is no subnet mask and there is no default gateway. So let me go ahead and hit cancel out of here. So we can see our networking is set up correctly. In a RAC environment, you're going to need to have your etc host files configured, and then you're going to have to bind those specific IP addresses to the appropriate NIC cards. Each individual node will need to have a minimum of 2 physical NIC cards, one for your public IP address and one for your private IP address. Now this is all on node 1. I'm going to go ahead and quit out of here. And then I'm going to come over to node 2. Because we're using etc host, we should have the exact same etc host file on each individual node. If I look at that over here on node 2, I can see that we have the exact same etc host file on each individual node. The same public address, the same private address. I'm going to go ahead and quit out of here. Now I'm going to go over to System, and this is on node 2, Administration and Networking. I'm going to give it the password of Oracle. And if I come over here on Active and I look at ETH0, I go to Edit, I can see that that's mapped to IP address 192.168.2.102 with the appropriate subnet mask as well as default gateway. That's exactly right. Let me cancel out of here. And then I go to ETH1 and I edit on ETH1, and I can see that it's mapped to 192.168.0.102. I go ahead and click OK. I do a file or quit. I do not want to save my changes. This is very important. Before we can deploy anything, we will need to ping the appropriate IP addresses. So from node 2, I'm going to ping RAC 1. Here I'm going to do a Control C, and I'm able to hit it. I should also ping rack1-private, or the private interconnect, and I can do that as well. Just to make sure everything works fine, I'm going to ping rack2 from rack2, which I should be able to do no issues. And then I should be able to ping rack2-priv. And that works fine too. Hit Control C and I'm out of it. Now I come over here to rack1. From rack1, let's ping rack2. We can do it. Let's go ahead and ping rack2-priv. We can go ahead and do it. And let's ping rack1. Again, we get response. And ping rack1-priv. We get response. So this is kind of how we want to set up the rack. The real question is, why do we want to use rack? The number one reason you will use rack is for high availability. You will not necessarily use your rack environment for better performance. You might be able to do it for better throughput, but you will not do it necessarily for better performance. You do rack or implement a rack environment because you'll get high availability. You can also route specific applications to specific nodes. But the huge advantage to rack is I do not have a single point of failure. In a single instance environment, you have a single point of failure, which is that node. If that node goes down, then the database goes down. In today's real-world environments, our actual data files are stored on SANs and NAS and multiple array devices. So those are typically not our single point of failure, but an individual node is. So what we can do is that we can install the database software on multiple nodes, create multiple instances pointing to a common set of data files. Our end users will just connect to a service, and that service can be called Oracle. Behind the scenes, Oracle can actually be routed to 4 specific nodes. Within that node, we're going to connect to a specific database, which is located on our NAS, our network storage. Then, if the node that they are currently connected to fails, it's no problem. In a racked environment, it will automatically fail over to a surviving node. Now, obviously, if the entire thing goes down, then we've got an issue. But the whole point of a rack environment is to provide ourselves high availability. We have multiple nodes sharing a common set of data files.